Okay, so once again, this question is set up pretty well for a substitution. Why? Because we already have one of our variables isolated. Y is isolated, and so is the other one. So it actually makes it really easy to substitute. So we can take this expression, the x plus 4. Since x plus 4 is equal to y, then we can substitute it into the other equation. So we create one equation, x plus 4 is equal to x plus 2 squared minus 4. Okay. Our goal is to solve for x. So that could include expansion, that could include combining like terms or bringing terms over from one side to the other in order to solve for x. All right, so let's start with expanding this part. I think this would probably be kind of the best, and we can combine like terms after that. This means x plus 2 times x plus 2. And then we'll bring down the rest. So what do we have? Well, we expand, we get x squared. X times 2 is 2x. 2 times x is another 2x. And then 2 times 2 is positive 4. Bring down the minus 4 and the x plus 4 on the other side. Okay, so we can combine like terms. 2x and 2x is 4x. So we have x squared plus 4x. Negative 4 plus 4, these actually cancel each other out. So we have x squared plus 4x on one side and then x plus 4 on the other. All right, so from here, we want to bring all the terms over onto one side because we want to try to factor the quadratic, right? If we can factor it, then we can solve for x, right? We might have 1x or 2x's that we then have to plug in, right? Depending on how many intersections are happening. So we subtract x on both sides. That gives us 4 is equal to x squared plus 3x. And then we can subtract 4. So that leaves us with 0 is equal to x squared plus 3x minus 4. All right, now that we have the quadratic all by itself on one side, and it's equal to 0, we can factor now. So open up my factors. I have x times x. That's the only way I get x squared. And I need two factors, two numbers that multiply to be negative 4, but add up to be positive 3. Any ideas on what those factors could be? 4, negative 1. Okay, yeah. Positive 4, negative 1 equal to 0. Okay, so then we want to solve for x. So x plus 4 is equal to 0, right? This is where we split. And x minus 1 is equal to 0. So it looks like we're going to have two solutions for x. X is equal to negative 4. X is equal to positive 1. Now, would we say we're done here, that we found our solutions for x, so we're done? What else would we need to find? Wouldn't we need to find the y value for these x values? If I have 4 as an x value, I would need to find out what's the output then, what's the y value. So remember, you get to pick whichever equation you want. I think this one is probably the easiest and the fastest. So we have y would be equal to negative 4 plus 4. So y is actually equal to 0. So I have a coordinates, right? I have a coordinate negative 4 comma 0. This is where we should anticipate a solution or an intersection between the quadratic and the line. All right, now we do the same when x is equal to 1. So y is equal to 1 plus 4. So y is equal to 5. So we should have a point of intersection at 1 comma 5. So these would be my two solutions right here, right? These are represent solutions to the system. Okay, any questions there? So as far as factoring, remember, this is a simple one where I don't need to do any Xbox methods because my leading term is already 1. Right? So that's probably the easiest one to factor. That's just a factor of x times a factor of x will give us 1x squared. And then the second question that we ask ourselves is, how do I factor the -4? I need factors that multiply to -4 but add up to be +3. So two numbers that do that would be 4 times -1. 4 times -1 gives us -4, but they add up to be +3. So that's how I ended up factoring. Okay, this is the traditional method for factoring that I taught you in Unit 4. All right, any questions on number 2? So it's likely that sometimes you have only one solution because it's only one point of intersection. Other times it's likely you have 2 points of intersection. All right. And again, what's the one for sure way you can check your work? You can graph. There you go, right? So we can graph it in Desmos and confirm that these are the intersection points. So we have x plus 4. And then we also had x, what was it? Was it x plus 2 squared? I think it was -2. No. -4. Okay. Okay, so what were our 2 points of intersection? I think we had one at -4, 0, right? That looks correct. Another one at 1, 5. Right? You want to zoom out a bit, make sure that there's no other intersections. Doesn't seem like we have any. Those are my only 2. All right, pretty cool. All right, let's go back now to example number 3. A little bit tougher, but doable. Okay. Here we have 2 functions. One of them is not quadratic. In fact, this is a circle. Some of you might recognize it from your Desmos project. You may have used circles, you got familiar with them. So this is the equation of a circle. And then we have a line, y equals -x plus 4. We still want to use substitution, right? So I always go to the equation that has an isolated variable. And the one that is isolated is y equals -x plus 4. Y is already by itself. So we get to sub whatever y is equal to. In this case, y is equal to -x plus 4. So guess what? We're going to plug it into the other equation where there is a y, right? The whole point of us being able to do this is so that we only deal with one variable at a time. So when I do the substitution, what I'll get is x squared plus, instead of y, it's going to be -x plus 4. And then we square that, and that should equal 16. So you see what I mean by we only work with one variable at a time is that when we do the substitution, we went from x and y to just x, right? X is the only variable that I have now that I have to work with. All right, notice how very important to use parentheses whenever you do a substitution, right? We're replacing only the y, and we then have to square whatever gets plugged in. So in this situation, we got to do a little bit of a side work. We want to take -x plus 4 and square it. So -x plus 4 times -x plus 4. If we distribute, that gives us a positive x squared. -x times 4 would be -4x. 4 times -x is another -4x. And 4 times 4 is a positive 16. This equals 16, and then we could also bring down the x squared at the front. Okay. So let's combine like terms wherever possible. Looks like we have x squared plus x squared. That means we can do 2x squared, right? 2x squared. -4x minus 4x. like terms as well. That gives us negative 8x. All right, plus 16 equals 16. Okay, so what do we want to do from here, right? If we were going to solve for x, where do you think we should go next? Yeah, we want to subtract 16 from both sides. Right, that way we end up with 2x squared minus 8x is equal to 0, right? That's actually kind of nice. So it's already set equal to 0. We can factor, we can solve for x. All right, I have 2x squared minus 8x. What could I factor out of both? Right, we always check for GCF, right? So if we can divide both by 2x, that's good. We have 2x times x minus 4 equal to 0. So it looks like we might get two solutions. 2x is equal to 0, and x minus 4 is equal to 0. Solve for x equals 0. That's our first solution. Second solution, add 4, x equals 4. So I have these two x values. I need to then go back to my original functions and try to find a place to plug it into. Okay, out of my two functions, probably the easiest one will be the bottom one, right? Y equals negative x plus 4. So let's go ahead and do that. Y equals negative, what's x? X is 0 plus 4. So y is equal to 0 plus 4. Y is equal to 4. So I need a coordinate, right? When x was 0, y was 4. That's one solution. And then we're going to do the same when x is 4. So y is equal to negative, plug in 4 plus 4. That's going to be negative 4 plus 4, which is 0. So for my other x value, it's kind of the reverse, right? It's flipped around. I have 4 comma 0 as my solution. And that's our x, that's our y, that's our x, that's our y. Okay, any questions there for number 3? All right, last one, number 4. Let's go ahead and work on this one. Okay, so again, we're working with substitution. If you have a variable that's already isolated, that's the one you want to start working with. So I have these two functions, these two equations. All right, notice how y is by itself. Y is by itself on one side of the equal sign. That's what I mean by isolated. So if it's isolated, we're going to bubble or circle the other side. And we're going to look for where is y, right? Where is y in the other equation? We're going to go and plug it in for y, right? Substitute. So then this should help us move everything so that we're only working with the variable x. So what we have now is 2x squared plus 10x plus 48 is equal to, what's my y? My y is actually negative 4x squared minus 16x. And then we have minus 10x. All right, so the parentheses actually aren't doing much right now. There's nothing that's going to be distributed into them. In fact, I could just get rid of them. So let's see what we can do in terms of collecting and combining. I have these two terms which are like terms. We can combine those. 2x squared plus 10x plus 48 is equal to a negative. 4x squared minus 26x. Okay. So now let's go through, move all the terms over to one side, and then hopefully we can factor it. And if we can factor it, then we can solve for x. So let's add 4x squared to both sides. And let's add 26x. These two terms, they go down to 0. But on the left side, we have 6x squared plus 36x plus 48. So if I wanted to factor this, where should I begin? How should I start? Yes, divide a 6 out. That's what they all have in common. So factor out a 6, that gives us x squared plus 6x plus 8. Now remember, there's no such thing as setting 6 equal to 0. 6 was something that got factored out, but it's only an integer. So we can actually divide both sides by 6 to get rid of that for us. Now what we have is x squared plus 6x plus 8 is equal to 0. 0 divided by 6 is still 0. And then lastly, we want to factor this. We want to factor it. Let's find our solutions for x. I know x squared is the easy one. That's x times x. Factors of 8 that add up to be 6. What could those be? Two and 4, that's right. Positive 2 and positive 4. So now we're going to split x plus 2 equals 0, x plus 4 equals 0. So x will equal negative 2, x will equal negative 4. Would we be done at this point?
I know where he's at. He's right there. Yeah, but everyone always looks that way. It's because he used to have his S there.
Right, correct. We're not done, right? So what do we need to find? We have our x values. We need to find the y values, right? So we go back up and we find an equation that is fairly easy to plug something into. Seems like second equation is probably the easiest one, right? It's got the one probably the least amount of work. So we have negative 4. For the first one, we're testing negative 2. So negative 2 squared minus 16 times negative 2. That will equal our y value. Okay. This is for when x is equal to negative 2. Okay. So go ahead and work that one out. As well as the other one, we want to find out what the y value will be when x is equal to negative 4. So for when x is negative 2, let's see what we get. Negative 4 times, well, negative 2 squared is just 4. Then negative 16 times negative 2, that's actually going to turn this into a positive 32. So negative 4 times 4 is negative 16 plus 32. That equals y. So if we combine these two, that's actually just positive 16. So a coordinate would be negative 2 comma positive 16. Right? That's one solution. This is where the two curves will intersect. Now let's try the other one. Negative 4 times negative 4 squared, that's 16. And then negative 16 times negative 4, that's positive 64. So here, when we multiply negative 4 times 16, that's a negative 64. Plus 64, y ends up just being 0. So we have another coordinate at negative 4, 0, where the two curves will intersect.